Section 3.2 will talk about physical and chemical properties and changes of matter. A property is a characteristic that describes something, and in chemistry we have physical and chemical properties to describe matter. A physical property is a characteristic that can be determined or measured without changing the substance's identity, whereas a chemical property is one that can be determined or measured as the substance is actually going through a change in identity. Some examples of physical properties would be color, odor, texture, boiling point, in fact any of the points, melting point, freezing point, density, solubility, which is the ability for a substance to dissolve in a certain amount of water, volume, mass, hardness, and malleability or brittleness. Malleability is the ability to bend and mold into different shapes. All of these characteristics describe a substance as it just sits there without it actually going through a change. Physical properties are just describing the appearance of a substance. Here's a quick slide just showing you some selected physical properties of water, and you can see that there are a couple on here that I've just mentioned. We've got the melting point or the boiling point, of course the mass of water, the density, and of course you can see that there are some others that we'll get to their meanings later on in the year, but viscosity, surface tension, any of the heats of fusion or vaporization, and so forth. Examples of chemical properties would be burning, combusting, which is basically burning, rusting, rotting, flammability, reactivity, neutralization, decomposition. These are all words that are showing us that a substance will be changing its structure and becoming something new. So it's describing a change in appearance of a substance. So physical properties can be further broken down into intensive and extensive properties. If we think about the prefix in and its meaning not, that will help us formulate a definition for this term. And basically an intensive property is a characteristic where the size of the sample does not matter. Whether you have a big piece or a small piece of that type of matter, the property would be the same in respect to both of them. To give you an example, let's talk about an aluminum BB versus an aluminum sheet of foil. Intensive properties could be characteristics such as the color, silver, the luster, be shiny, maybe the texture, smooth, maybe the hardness, they would both be hard. Whereas extensive properties, those are characteristics where the size of the sample does matter. And that means that the properties would be different depending upon the size. In this case, an aluminum BB might be less mass than an aluminum sheet of foil. The aluminum BB might have less volume. You can see with both of these examples, different sizes would definitely give you different characteristics of mass and volume, and we could even go on and talk about length as well. Intensive properties can be things like melting point, boiling point, the density of a substance, color, smell, conductivity, and hardness, whereas extensive properties would be things like mass, volume, energy, length, and shape. If we take a look at the two pictures above, you will see that we have samples of sulfur. They are each 2 centimeters in length. And if you take a look in blue, you will notice that there are some intensive and extensive properties. Our intensive properties could be things like color and melting point. Notice that they both are yellow and they both have a melting point of 115.2 degrees Celsius. It doesn't matter about the size of the sample. Whereas extensive properties are dependent upon how much you have, and you can see that they are reflecting on the mass. You can see that the sulfur crystals have a larger mass, and they also have a larger volume than the powder. This is our first self-check of this section. You're going to determine if each property is physical. We'll use the abbreviation P, or chemical, the abbreviation C. Go ahead and turn the vodcast off and turn it back on when you're ready to hear the answers. All right, flammability is going to be a chemical property. Anything that is flammable is going through the process of combustion, and the structure will change during that process. Boiling point, solubility, and malleability are all physical properties. These are characteristics that are describing a substance that will not be changing its identity. Remember, boiling point is the temperature at which a liquid turns to a gas. Even though the state of matter is changing, the actual structure is not. Solubility is the ability to dissolve. The solute is dissolving in the solvent. Both the solute and the solvent aren't really changing their identity in that process either. And then the last one, malleability, is the ability to change shape. So once again, the substance is not changing its identity at all. It's just changing the way it looks. Reactivity with oxygen actually is combustion, and that would also be a chemical property as well. So let's talk about physical and chemical changes now. You will see that on the far right we've got an example of some fireworks. That is an example of a chemical change, and it's kind of blurred, but over to the left you can see it looks like maybe dry ice in water, and what's happening is that dry ice is going from a solid to a vapor form, and so that would be an example of a physical change. So a physical change is one where the substance will look different, okay, but it will not actually be a different substance. If you take a look at the example down at the bottom, you will notice that this is a physical change because both the reactant and the product is the same substance, which is H2O. So the chemical formula did not change. However, the way that substance is going to look is going to change. The liquid initially turns into a gas. The chemical change, not only is the substance going to look different, it is going to be different. If we take a look at the reactant this time, we've got water, H2O, but the products are actually hydrogen and oxygen gas. So the chemical formulas are actually changing here. Recall that another name for a chemical change is called a chemical reaction. There are some buzzwords that will help you identify a physical change. Words like breaking, dissolving, distilling, cutting, any change of state, boiling, condensing, melting, and freezing. Remember that physical changes do not produce new substances. Chemical change buzzwords would be things like rusting, burning, metabolizing, reacting, combusting. These are going to be changes where new substances will be formed. If we take a look at our example to the right, you will see in the first illustration that wood is being chopped. We know that that wood will be in smaller pieces at the end of that process. That is a physical change because whether I'm looking at large logs of wood or small pieces of wood, wood is still wood. The chemical structure is still the same. But if I take that wood and I react it with oxygen and go through the process of combustion, it will be a chemical change. Not only will I have ashes at the end, but I will also have produced carbon dioxide and water. All three of these things are different substances than the initial wood that we started with in this process. So just take a few minutes to look at all the illustrations and captions next to the illustrations to help you differentiate between physical and chemical changes. When you're finished with this, go to the next slide. So another way that we can identify a physical change is if you know that that change can be undone. For example, if we take salt and we dissolve it in water, it seems to disappear. And many people used to think that's a chemical change. But if you were to actually get on the microscopic level, you would see that both the water and the salt are still present. They're just kind of evenly mixed into one another. They have formed a solution. And that actually is a physical change. If we were able to evaporate that water, we would get the salt back. So if a change can be undone by a physical change, then the original change was probably physical as well. Here are 4 terms that are sometimes classified incorrectly. The first one is melting. Remember, that's just a change of state from solid to liquid. The identity of the substance stays the same, so that is physical. We've got burning. That would be when a substance is reacting with oxygen. It will produce carbon dioxide and water, completely different substances, so it would be chemical. Dissolving, which is adding one substance to another to form a homogeneous mixture or a solution. That is definitely physical. We just talked about how those two substances keep their own properties. They just evenly blend together so that they look that they're different, but they're really not. And then drying. Drying is just basically heating a sample by evaporating the water, and that would be a physical process. Any change of state is physical. You can also identify the difference between a physical and a chemical change by recalling those possible signs of a chemical reaction. If we see bubbles, that usually indicates that gas is being produced. If our substances are changing temperature, or they're giving off light, if they change their color or form a precipitate, these were indicators that the change that we're looking at is a chemical change, that the substances in the beginning and the end will be different. Be careful with those possible signs because sometimes they can accompany physical changes as well, such as the bubbles that are formed during the process of boiling, the energy changes that accompany the changes in state, and color changes that can occur to different concentrations of a solution being made. All right, this concludes section 3.2. Once again, lots of practice in class to help you identify the difference between physical and chemical properties and physical and chemical changes. Have a great day.